Nowadays, we hear a lot about climate change and how we can lessen its impacts. We're told that the solution is to drive less, cycle to school, walk to work, maybe even take the bus downtown. But whether or not we drive to get around is only a small part of the equation when it comes to climate change. You might think that because you don't drive, you aren't part of the problem. But that phone in your pocket right now, it had to get here on a ship, a plane, or a truck. You might walk to the grocery store, but the groceries you bought definitely didn't. They too had to get on a plane, ship, or truck. So whether we like it or not, we've become so dependent on our transportation systems that simply banning trucks or reducing the number of flights we take just isn't a solution anymore. What can be a solution is changing the fuel we use to propel our vehicles. At our lab, we developed a simple process to convert any waste fat or oil into a renewable and sustainable fuel. Now, this renewable fuel is suitable for land transportation equipment like cars and trucks. But what about planes? Can we use this renewable fuel on planes? In other words, can we go from waste to wings? Now, that question is at the heart of my research. And as it turns out, we can't use that renewable fuel on planes just yet. The reason being, our renewable fuel freezes at minus 10 degrees Celsius. But when you're 30,000 feet in the air, temperatures are way colder than that, and our fuel would freeze. And trust me, 30,000 feet in the air, you don't want your fuel freezing. Now, fuel freezing is a lot like building a wall. When the bricks are uniform and easily stackable, it's very easy to build a strong, solid structure. When the bricks are jagged, they're less easily stackable, and it's much harder to build a strong, solid structure. Likewise, in fuel, the molecules can be stackable or not so easily stackable. In the top right of the slide, we have what we call normal chain molecules. And like the uniform bricks, they tend to stack up and solidify. On the bottom right, we have what we call branch chain molecules. And due to the irregularities in their shape, they're less likely to stack up and can remain liquid even at very cold temperatures. Where I'm at with my research right now is I've been able to develop a suitable mineral powder that when placed with our renewable fuel can convert the normal chain molecules into branch chain molecules, therefore lowering the freezing point of the fuel. By further developing this method, we can go from landfill to runway and hopefully go on a vacation without feeling too guilty about climate change. Thank you.